You know that feeling. The AI world is evolving at, well, lightning speed, and you want to understand how it's impacting software, how to get ahead, maybe, without feeling like you're just completely in over your head or missing some critical piece.
Hmm.
That's exactly what we're tackling today.
Yeah, we're taking a deep dive into something called improvement engineering.
Right.
You can think of it as like a strategic advantage in how we develop and run software, especially now with AI becoming so integral.
Right.
It's about getting thoroughly informed, but, without the usual information overload.
Precisely. And this isn't just theory, right? We've gathered some really insightful material articles looking into the nuts and bolts of improvement engineering, how quality engineers are actually evolving into this field, and some key takeaways from recent research.
Yeah, good stuff.
So whether you're, deeply technical or maybe just curious about this whole AI revolution, this deep dive is really designed to give you the essential principles and a clear understanding of how quality itself is changing in this AI-driven landscape. Our mission today really is to extract the core value, those crucial insights about improvement engineering and its impact, especially on quality engineers. Okay, let's get into it then. What exactly is improvement engineering?
Okay, so at its core, improvement engineering is really a blend of disciplines. It combines the practical methods of like AI engineering with established continuous improvement approaches. Things like Lean, Six Sigma, Toyota Kata.
Classics.
Exactly. Plus, smart software process optimization. What's interesting, I think, is that it goes beyond the traditional roles of just quality assurance or even, say, DevOps.
Okay.
The fundamental shift is a very deliberate focus on ongoing data-informed improvement. It becomes a central part of the engineering work itself.
So it's not just about fixing problems when they pop up, is it? It's more about constantly refining and enhancing the whole process.
Precisely.
What are the sort of fundamental ideas behind this?
Well, there are several key guiding principles. First up is the continuous improvement mindset. This is deeply rooted in the Japanese concept of Kaizen.
Kaizen, right. The core idea is basically that no product or process is ever truly finished. There's always an opportunity to eliminate waste or reduce errors or enhance the value you're delivering.
Always room for improvement.
Exactly. This requires building feedback mechanisms, feedback loops into every stage, and really viewing each release, each iteration as a chance to learn and get better. Continuous improvement's been, cornerstone of quality management for decades, and now it's being strategically applied to software and AI systems.
Always striving for better. That makes a lot of sense, yeah.
What's the next key idea?
Second is adopting a scientific approach to problem solving. This is heavily influenced by Toyota's methods, especially the Toyota Kata.
Ah, Kata.
Yeah, it's basically an experiment-driven way to make changes. So instead of just jumping straight to implementing solutions, teams learn the structured routine. They set clear target conditions, run small experiments to move towards those goals. Little steps, exactly. And they actively coach improvement at every level.
Mm-hmm.
It's all about hypothesis testing and learning from what happens, using cycles like Plan-Do, Check, Act, A/B tests. This method really aims to build a shared mindset of continuous learning and adaptation across the whole team.
So less guesswork, more actual testing and learning, I see. Okay, what else is essential here?
The third principle is the integration of Lean and Six Sigma. Think of Lean as, well, ruthlessly cutting out anything that doesn't directly add value in your software process, like unnecessary meetings or maybe overly complex approval flows.
Getting rid of the fluff.
Exactly. Six Sigma, on the other hand, brings this like data-driven laser focus to squashing defects and making your processes super consistent, really reliable, aiming for near perfection.
Okay.
So in improvement engineering, this could mean streamlining workflows, getting rid of redundant steps, combined with using statistical tools to monitor quality, like value stream mapping. Imagine drawing a flowchart of your entire software delivery process.
From start to finish.
Yeah, from the very first line of code right to when it reaches users. Value stream mapping helps you visually see those slow, wasteful steps, maybe a handoff between teams that takes days,
Right.
So you can target those areas. And Six Sigma's DMAIC framework, define, measure, analyze, improve, control that can be used to systematically fix, say, a slow testing process.
Okay.
The emphasis on data is huge here, using metrics and statistical process control charts to spot process issues in real time, much like they do in manufacturing.
Mm-hmm.
Combining Lean's focus on speed with Six Sigma's focus on quality, the goal is faster delivery with fewer errors. And what's really fascinating now is the synergy with AI. AI-driven analytics can even enable predictive quality control, making those traditional methods even more powerful.
Wow, AI helping us predict quality problems before they happen. That sounds like a pretty big advantage. What's the fourth core principle then?
That would be AI-empowered automation and feedback.
Hmm.
This is where improvement engineering really starts to leverage the power of, well, the AI era we're in.
Yeah.
Modern systems, think generate just vast amounts of data logs, user behavior, system metrics, you name it. Improvement engineers use AI and ML techniques to analyze all this data and find opportunities for enhancement.
How so? Like, give me an example.
Okay, imagine machine learning models that can actually predict which parts of your code are most likely to have bugs.
Seriously?
Yeah, guiding developers where to focus their refactoring efforts. Or in testing, you've got generative AI that can automatically create a much wider range of test cases, maybe even help systems self-heal when things go wrong.
Self-heal. Wow.
Yeah. AI can continuously learn from operational data, identify patterns and quality issues, and suggest optimizations. Things like intelligent monitoring or AI ops that flags anomalies in deployment pipelines, to even recommendation systems suggesting ways to improve sprint planning. AI becomes this incredibly powerful tool for continuous improvement. But of course, you need to follow solid AI engineering principles to make sure these AI feedback loops are actually reliable and trustworthy.
Right, you need to trust the AI giving the feedback.
Exactly. So AI is kind of both a thing being improved and a key tool for improvement.
Okay, so AI is pretty central here. And the final key principle.
Finally, there's software process optimization and DevOps alignment. Often you'll hear this referred to as CI/CD/CT, continuous integration, continuous delivery, and importantly, continuous training for the ML models.
Ah, the CT part is key for AI.
Absolutely. Improvement engineering aims to optimize the whole software lifecycle, reducing friction, increasing how often you deploy and how reliably you do it, often tracked with DORA metrics.
DORA metrics, right. The vital signs.
Yeah, think of them like the vital signs for your software delivery engine. How often you deploy, how long it takes to recover from a failure, how often changes cause problems. Improvement engineering relies heavily on tracking these to see if the improvements are actually working
Makes sense.
and ensuring that you learn from incidents, right? Through things like blameless post-incident reviews, root cause analysis like using the 5 whys technique, and experimenting safely using feature flags or canary releases.
Safe experimentation.
Yeah. And for ML systems specifically, there's MLOps, which is basically an ML engineering culture focused on automation and monitoring at all stages of building an ML system. The ultimate goal is a high-performing engineering system that can continuously adapt and improve with, ideally, minimal manual intervention.
Okay, so just to summarize then, improvement engineering takes this really holistic view, looking at the technology, the processes, and the people involved, all working together to continuously improve both the products we build and the way we actually build them.
That's a great summary. Exactly. Now, maybe we should talk about how this translates into, practical steps. What are some of the key practices and methodologies that improvement engineers actually use?
Yeah, tell us more. What does this look like in action?
Okay, well, one of the most fundamental practices is data-driven decision-making. The core idea here is that decisions about what to improve and how should be grounded in solid data, not just gut feelings.
Right, evidence.
Evidence, exactly. Improvement engineers focus on setting up metrics and observability right from the start. For example, an improvement engineer might track how long it takes to deploy code or the rate of errors users are hitting. If the data shows, say, a big spike in page load times, that could kick off an improvement project right there. And this isn't just about glancing at dashboards. It often involves statistical analysis to really pinpoint the most impactful improvement opportunities. Because, the loudest problems aren't always the most critical ones.
Okay, so let the data guide where you put your effort. What's another key practice?
Continuous feedback loops are absolutely crucial. In software teams, this means setting up monitoring and user feedback channels so information gets back to the engineers quickly.
Like closing the loop.
Exactly.
Right.
Techniques like feature flagging, where you release a new feature to just a small group of users and watch its impact closely. It's basically a mini Plando check-act cycle happening live. Agile sprint retrospectives also become more focused, using data and driving action in this context. They feed into an overall improvement backlog. And the Toyota improvement Kata routine we mentioned, that's often used to provide a structured way to set short-term goals, experiment, and learn constantly. The real objective is to build a culture where every single iteration makes the system measurably better.
Feedback coming in from everywhere, the code, the users, the team itself. Makes sense. What about how the work actually flows? How does that get improved?
Right. That leads us to lean process mapping and waste elimination. Improvement engineers often act a bit like process architects, analyzing how work actually moves through the system.
Mapping it out.
Yeah, they might create value stream maps of the software delivery pipeline, like we discussed, to visualize all the steps and spot bottlenecks or
Yep.
delays.
See where things get stuck.
Precisely. By doing this, they can pinpoint and eliminate waste in the process, things like too many handoffs or unnecessary approval steps, waiting time. Then they apply lean principles to improve the flow. For example, reducing the size of code changes and deploying more often, or getting rid of redundant testing, maybe automating manual checklists. Think about that journey from a developer writing code to it being live if there are multiple teams and long waits. An improvement engineer aims to streamline that, probably with a better DevOps pipeline using automated testing and deployment.
Right.
You see companies like Amazon applying these lean principles really effectively, maximizing productivity by focusing on automation and cutting waste. In software, that might mean using infrastructure as code and one-click deployments instead of manual error-prone setups. It's about constantly chasing efficiency, removing anything that blocks a smooth workflow.
Streamlining the flow, cutting out the waste, classic lean thinking. Now, how does quality assurance fit into all this?
Ah, good question. That's where Six Sigma and quality control techniques come into the picture. From Six Sigma, improvement engineering borrows the focus on minimizing defects and controlling variability, making things consistent. This translates into building quality checkpoints and analytics throughout the software lifecycle. For instance, an improvement engineer might set up automated quality gates in the CI pipeline.
Like a toll booth for quality.
Kind of, yeah. If code coverage drops below a certain level, or maybe the number of static analysis warnings goes above a threshold, the build fails automatically. It prevents issues from moving downstream.
Catches problems early.
Exactly. They might also use things like control charts to track key metrics, like the number of new bugs found per testing cycle, to see if the process is stable or if something's gone wrong. And the DMAIC framework we mentioned, that's used for specific improvement projects, like maybe defining a goal to reduce production defects, measuring the current rate, analyzing the root causes, perhaps not enough testing in one area, then piloting improvements like better code reviews or maybe AI-driven tests, and then monitoring the defect rate afterwards to see if it worked. By using these methods, organizations can speed up delivery, cut costs, and use resources better. Some even apply design for Six Sigma ideas to software architecture itself, designing modular systems that are easier to test, for example.
So quality isn't just a final check at the end. It's built in and constantly monitored using data. Now, you mentioned earlier that AI plays a pretty significant role here. How exactly does AI boost these improvement activities?
Yeah, this is where things get really interesting, I think. AI-augmented improvement activities represent a really cutting-edge part of improvement engineering.
Okay, tell me more. How is AI being used to make the improvement process itself better?
Well, one crucial way is through predictive analytics for processes. Machine learning models can actually be trained on historical project data, things like past releases, bug reports, code changes,
Okay.
to forecast things like the likelihood of an upcoming release being delayed, or maybe which specific part of the system is most likely to fail in production.
Wow, like an early warning system.
Exactly. It gives the team a heads up, allowing them to take proactive steps. For instance, an ML model could analyze code commit patterns and test results to predict if the current build is likely to have a critical bug hiding somewhere.
So AI helps us see potential problems coming and maybe head them off. What else?
Another big area is intelligent testing. AI-driven test generation tools can create a much broader range of test cases, including those tricky edge cases that humans might easily overlook.
Finding the weird stuff.
Finding the weird stuff, yeah. And as one expert put it, generative AI can analyze past data to kind of anticipate where future issues might pop up, helping catch bugs before they even get close to production. AI can also optimize testing, learning which tests are most likely to find failures and prioritizing those. That's smart regression testing.
Smarter, more comprehensive testing driven by AI. That sounds like a real leap forward. Okay, what's next on the AI front?
We're also seeing the rise of self-healing systems. These are systems designed to automatically detect and resolve issues when they happen.
Without human intervention.
Ideally, yes, or with minimal intervention. For example, if a cloud service has an outage, automated processes, maybe guided by AI, could trigger failovers or restarts automatically.
Hmm.
Improvement engineering involves setting up and constantly refining these kinds of mechanisms. The big vision here is moving towards autonomous testing pipelines. Pipelines that can learn from past results and adapt themselves, perhaps adding new tests or adjusting monitoring thresholds, all on their own.
Systems fixing themselves and testing pipelines that evolve autonomously. Well, that's pretty advanced stuff. Are there other ways AI is helping with improvement?
Yeah, one more area is through process mining and bots. AI-based process mining tools can analyze event logs from all sorts of development tools, version control, issue trackers, CI/CD systems,
Okay.
to automatically map out how work actually flows, not just how we think it flows. And they can pinpoint where the real delays are happening.
Finding the hidden bottlenecks.
Exactly. An improvement engineer might use this to discover, say, that code reviews are taking way longer than expected. Then they can work on solutions, maybe even using an AI assistant to suggest code improvements to speed up those reviews. We're also seeing chatbots and AI assistants used to guide teams through retrospectives or answer process-related questions, helping with knowledge sharing and consistency.
So AI is helping us understand our own processes much more deeply and even giving real-time help. It really seems like technology is a huge piece of improvement engineering. But what about the people side, the human element?
Oh, absolutely critical. Despite all the focus on tools and techniques, improvement engineering is fundamentally human-centered. It has to be. It recognizes that improving processes always require shifts in how people behave, how they think, and how they work together.
Okay. What kind of human-centered practices are we talking about here?
Well, one really important practice is conducting blameless postmortems. This idea comes largely from site reliability engineering. When an incident or a failure happens, the focus is squarely on understanding what went wrong with the system or the process, not on pointing fingers at individuals.
Learning, not blaming.
Exactly. The goal is to identify concrete steps to prevent the same thing from happening again. This encourages team members to speak up openly about problems, even early on, without fear, and to view failures as valuable opportunities for learning and growth. Think of it like a sports team reviewing a game they lost. The goal isn't to blame the player who missed the shot, right?
Right.
It's to understand what went wrong with the overall strategy or execution so they can improve for the next game.
Creating that safe space to learn from mistakes, yeah, that sounds absolutely essential for making progress. What else?
Coaching and training are also vital. Improvement engineers often take on a coaching role, a bit like the Toyota coaching Kata we mentioned, where managers guide their teams through that structured improvement routine.
Guiding the process.
Yeah. They might train teams in specific techniques like how to do effective root cause analysis or how to read a control chart. The aim, over time, is to empower everyone on the team to contribute to improvements. It reflects that total quality management idea that quality is really a collective responsibility.
So it's about equipping and empowering the whole team to be part of the improvement journey. Makes perfect sense.
Another crucial human-centered practice is encouraging incremental experimentation. People can naturally resist big, sudden changes.
Sure, change is hard.
It is. So the focus is often on encouraging small, manageable experiments rather than trying to implement sweeping changes all at once. The idea is to pick a focused area, run a pilot test for a bit, measure the results, and then scale it up if it actually works.
Test the waters first.
Exactly.
Mm.
This lets teams see real evidence of success and reduces the fear that can come with large-scale changes. Improvement engineering really tries to cultivate a safe-to-fail environment where trying new things is encouraged, and failures are seen as learning opportunities, as long as you learn from them quickly.
Small, safe experiments. Yeah, that seems like a great way to drive change without causing chaos. And finally, what's the last human-centered practice you wanted to mention?
Cross-functional collaboration is absolutely essential because improvement often cuts across different teams: dev, QA, ops, data science, maybe others.
Right, it's rarely just one team's issue.
Exactly. So it's crucial to bring these different groups together to tackle problems collectively. Improvement engineers might lead things like communities of practice or working groups focused on specific themes, like improving test automation, bringing together people from different teams who care about that topic. This helps break down those organizational silos and make sure that insights and solutions get shared broadly.
Fostering collaboration and shared learning across the org. Yeah. It sounds like improvement engineering is a truly comprehensive approach. Now, for all the quality engineers listening, you mentioned earlier they're actually really well positioned for this shift. Could you elaborate on that transition? What does it take for a QE to become an improvement engineer?
Absolutely. Yeah. Quality engineers, QEs, they already have a fantastic foundation. They usually have an in-depth understanding of testing, quality assurance principles, and software development processes.
They know where the bodies are buried, so to speak.
Huh, yeah, sometimes. The transition to improvement engineering is essentially about broadening their focus,
Mhm.
moving from looking only at product quality to enhancing the entire system that delivers that product.
Okay, so it's an expansion of their existing role and perspective. What are some of the specific areas where QEs might need to upskill or develop?
Well, one key area is definitely expanding their technical skill sets,
Mm.
particularly in areas like AML, MLOps, and observability.
Okay, let's break that down a bit. What kind of AML skills are we talking about? Do they need to become data scientists?
Not necessarily expert data scientists, no. But a solid grasp of fundamental AI and machine learning concepts is becoming essential. They should understand, how ML models are developed, how they're evaluated, how they're deployed.
The base.
The basics, yeah. Understanding concepts like training versus inference, model performance metrics, common failure modes in AI, like bias or drift. That knowledge enables them to contribute effectively to AI system reliability and also just use AI tools intelligently. Taking online courses, maybe doing small hands-on ML projects can build this foundation. And it's worth remembering, all ML algorithms are fundamentally software, so a QE's existing software engineering skills are still super valuable here.
Okay, so understand the basics of how AI works. What about MLOps? You mentioned that earlier.
Right, MLOps. Just like QEs have probably gotten good at CI/CD for traditional software, they now need to learn about MLOps. It's basically DevOps principles applied to the machine learning lifecycle.
Okay.
It focuses on automating and monitoring the entire ML process. This includes understanding continuous training, how models can be automatically retrained on new data and validated. They also need to learn about model deployment and monitoring tools to track how models are performing in production and detect issues like model drift, where performance degrades over time.
Keep an eye on the AI once it's live.
Exactly. And basic understanding of data engineering for ML, like data pipelines, is also important because model quality so often depends on data quality. Mastering MLOps lets QEs ensure that AI systems are reliable and continuously improving, which is, core to improvement engineering in this AI age.
MLOps applying DevOps to AI. Got it. What other technical skills are important for QEs making this shift?
Familiarity with cloud and automation tools is increasingly vital. So much improvement work leverages cloud platforms now.
Makes sense.
QE should get comfortable with the cloud services related to CI/CD, AI monitoring offered by the major providers like AWS, Azure, GCP. Spending time learning infrastructure as code tools, Terraform, CloudFormation, things like that, and configuration management is also really valuable because improving processes often involves automating how you set up development and testing environments.
Cloud and automation, yeah, pretty essential for modern software work and improvement. What about actually understanding what's happening inside the systems?
Right, that's where observability and analytics come in. Observability is just paramount for continuous improvement. You can't improve what you can't see.
True.
So QEs need to get skilled in setting up and interpreting logs, metrics, and traces using modern observability platforms. Datadog, Splunk, Prometheus, Grafana, the Elastic Stack, whatever the tool is. Knowing how to build dashboards, set up alerts, that's essential for getting the feedback needed to drive improvements.
Seeing these as signals.
Seeing the signals, yeah. And beyond that, familiarity with analytics and maybe BI tools can be really helpful for analyzing process data and showing the results of improvement efforts. Some QEs even pick up scripting languages like Python for data analysis. This analytical capability is crucial for digging into root causes and, importantly, for proving the impact of improvement work.
So being able to see under the hood and analyze the data that comes out, critical. And you also mentioned statistical process control and experimentation earlier.
Yes. To really excel in an improvement role, QE should probably learn the basics of statistical analysis as it applies to processes.
Statistics, okay.
Yeah, things like understanding distributions, how to use control charts effectively, basic hypothesis testing, maybe even design of experiments. For example, knowing how to use a statistical test to determine if a process change really improved cycle time, or using a control chart to monitor deployment stability that adds a lot of weight to recommendations.
More rigorous analysis.
Exactly. And learning about A/B testing and experimentation platforms, LaunchDarkly, Optimizely, etc., is essential for safely testing process changes or new product features on a small subset of users first. It allows for a controlled, measurable way to roll out improvements.
Okay. So it sounds like becoming a well-rounded improvement specialist involves picking up a range of these technical tools and techniques, but I imagine it's not just about the technical skills, is it?
Oh, absolutely not. Developing strategic and soft skills is arguably just as important, maybe even more so, for quality engineers transitioning into these improvement engineering roles. This kind of role often involves leading change and influencing others, often without direct authority.
Right, the people side. What kind of strategic and soft skills are we talking about?
Well, first, a deep understanding of continuous improvement methodologies themselves is key. QEs should really consider getting certifications or training in things like Lean Six Sigma, maybe a green belt or black belt, or Agile and DevOps leadership certifications, Toyota Kata coaching, maybe even quality management standards like ISO 9001.
Formalizing the knowledge.
Yeah. Lean Six Sigma, for instance, doesn't just teach you statistical tools, it gives you frameworks for actually leading improvement projects. And as one source pointed out, Toyota Kata training often starts with practicing these foundational routines, called starter Kata, that help you internalize that scientific way of thinking about problems.
So formal training in these methods can be super valuable. What other strategic skills are important?
Project and change management skills are crucial. Improvement initiatives are basically projects, right? They involve change. So knowing how to define the scope, plan the phases, things on track is important.
Standard project management.
Standard project management, yes. But also learning specific change management strategies is vital because, like we said, people can resist new ways of working. This involves developing skills in communication, facilitation, negotiation, all needed to get buy-in for new practices. Improvement engineers often need to influence teams they don't directly manage, so these skills are key.
Influencing without direct authority, yeah, that's a critical skill in almost any collaborative role. What about leadership qualities?
Transitioning QEs should really aspire to become leaders in this domain, not necessarily managers right away, but thought leaders, mentors in quality and improvement, developing coaching skills to help others improve, adopting more of a servant leader approach, focusing on making it easier for others to do high-quality work, and really consciously building trust and credibility. Those are all essential.
So guiding and empowering others to join the improvement effort. What other strategic skills come into play here?
Systems thinking and design thinking are incredibly valuable. Systems thinking helps you understand how a change in one area might affect, ripple through the rest of the system, hopefully preventing unintended negative consequences.
Seeing the big picture.
Seeing the big picture, exactly. And design thinking gives you a human-centered approach to designing processes. It emphasizes really understanding the needs of the people who use the process, and then designing improvements based on those insights, not just on technical efficiency.
Okay, seeing the whole system and designing for the people using it, crucial perspectives. And finally, in terms of strategic skills.
Business acumen. This becomes increasingly important. QEs moving into improvement roles really need to understand the business context of their work. What are the company's strategic goals? How does improving software quality or delivery speed actually impact key business outcomes like revenue, customer satisfaction, operational costs?
Connecting the dots to the bottom line.
Precisely. Being able to articulate the value of improvements in clear business terms, this change will save X dollars, or this will improve customer retention by Y%, that's crucial for getting support from leadership.
So understanding the why from a business perspective. Wow, it sounds like this transition demands a really comprehensive skill set, technical, strategic, people skills. Now, for QEs who are thinking about this career path, what kind of actual job titles or roles might they be looking at? What are some of these emerging career paths in improvement engineering?
Yeah, there are several really interesting possibilities opening up. One is, of course, the formal role of improvement engineer or maybe process improvement engineer. You often see these within teams called engineering excellence or something similar.
Okay.
In that kind of role, you'd be explicitly responsible for analyzing engineering processes and driving improvement initiatives across different teams or even the whole organization.
So a dedicated role focused squarely on making things better. What else is out there?
Well, with AI becoming so prevalent, we're definitely seeing roles like AI reliability engineer or AI quality engineer. Think of these roles as ensuring the reliability and quality of AI systems once they're in production. It's kind of like an SRE, a site reliability engineer, but specifically focused on AI.
SRE for AI.
Exactly. Involves monitoring model performance, detecting anomalies or drift, validating updates, setting up fallback mechanisms. As one example we saw mentioned, Deutsche Bank actually introduced AI reliability engineers to help them scale their AI implementations safely. These roles require a blend of QA, software engineering, and ML skills.
The SRE equivalent for AI, yeah, that's a really clear way to think about it. What other paths are emerging?
QEs with a strong interest in the automation side and ML might consider becoming MLOps engineers or perhaps ML test engineers.
Hmm.
MLOps engineers, they build and maintain the pipelines that get ML models into production reliably. That includes implementing testing specifically for models and automating retraining triggers. It really leverages a QE's CI/CD expertise and just extends it into the world of data and models.
Okay, so focusing on the infrastructure and processes needed to deploy and maintain AI systems reliably, what other directions could a QE go?
Some might transition into DevOps or DevX specialist roles. DevX meaning developer experience. These roles focus on enhancing the overall productivity and, well, the experience of the developers themselves.
Making life better for developers.
Exactly. This could involve building better test automation frameworks, optimizing CI pipelines, creating internal tools to automate common tasks. While not always exclusively AI-focused, these roles are increasingly using AI to help improve code quality or streamline development workflows.
Improving the day-to-day work of developers, yeah, that sounds like a role with a potentially huge impact. Any other career paths worth considering?
In large organizations, sometimes you see opportunities to become a process architect or maybe a business process engineer. These roles take an even broader view, looking at end-to-end processes that might span multiple departments, not just software development.
Wider scope.
Wider scope, yeah. QEs, who have that big picture perspective and skills in business process improvement, can do really well here, optimizing how different parts of the organization interact and collaborate.
Taking that wider view of how the whole organization works and finding ways to optimize it. And what about leadership opportunities in this space?
Definitely. On the management track, QEs with strong improvement engineering skills can certainly advance to become quality engineering leaders, or perhaps directors of engineering excellence. In these roles, they'd be shaping the quality strategy and the improvement roadmaps for the entire engineering organization. Some companies, like Microsoft and Google, have teams specifically dedicated to engineering excellence that these leaders might oversee.
Okay, leading the strategic direction for quality and continuous improvement at a higher level. And finally, any other roles that might be a good fit, maybe related ones?
Well, some QEs might even transition directly into site reliability engineer, SRE roles. SRE shares that core philosophy of continuous improvement, automation, and a deep focus on the reliability and scalability of systems.
Lots of overlap there.
Huge overlap.
Yeah.
And as we discussed, the SRE discipline itself is expanding to cover the reliability of ML systems too. It's important to remember, though, that job titles in this field are still kind of fluid and evolving.
Right.
So QEs should look beyond just the title and focus on roles where they can apply their skills in designing better ways of working and ensuring complex systems are dependable.
Mm.
Actively networking, maybe even proposing internal improvement projects. Those could be really effective ways to carve out these kinds of opportunities for yourself.
So, a really wide range of potential paths for QEs to explore as they embrace improvement engineering. Now, we've covered the skills needed, the potential roles, but you also really emphasize the importance of driving changes in the organizational culture. How can QEs who become improvement engineers actually help build that culture of continuous improvement?
Yeah, this is absolutely pivotal. You can have the best tools, the best techniques, but without the right organizational culture supporting it, improvement initiatives often just fizzle out. They don't stick.
Right, they don't become sustainable.
Exactly. QEs moving into the space are actually ideally positioned to be catalysts for these necessary cultural shifts.
Okay. So what are some of the key cultural changes they can help champion?
Well, one of the most crucial, I think, is promoting the understanding that quality is everyone's responsibility. Traditionally, QA or QE might have been seen as the gatekeepers, the sole guardians of quality at the end of the line.
The quality police.
Yeah, sometimes. But in modern agile and DevOps setups, quality has to be a shared responsibility. It spans development, testing, operations, everyone. Improvement engineers can actively promote this mindset, encouraging developers to write testable code from the start, getting operations involved in failure analysis, breaking down those silos between teams, concepts like shift left.
Testing earlier.
Testing earlier, yeah. And shift right.
Monitoring in production.
Monitoring and ensuring quality in production. Those help broaden the ownership of quality across the whole lifecycle.
Shifting the focus on quality so it's happening everywhere, all the time. Makes perfect sense. What's another key cultural shift they can push for?
Fostering a blameless culture and psychological safety. This is just vital for continuous improvement to actually take root and thrive.
Psychological safety, right? Feeling safe to speak up.
Exactly. Improvement happens best when people feel secure enough to admit mistakes, to point out problems, without fearing blame or punishment. Improvement engineers can lead by example here, especially in those post-incident reviews we talked about. Focusing on understanding how the system or the process failed, not who failed,
System, not person.
system, not person. By documenting the improvements that come out of these reviews, and maybe even celebrating when root causes are found and fixed, they reinforce the idea that finding and fixing weaknesses is a positive thing. When people feel safe to raise issues, you simply get better data and more chances to improve. Research, like the Dora reports, consistently shows a strong link between psychological safety and team performance.
Creating that environment where people feel safe to speak up, learn from errors. Yeah, that feels fundamental for improvement. What's next in terms of cultural shifts?
Cultivating a scientific mindset and a real willingness to experiment. This means promoting the idea of making decisions based on data and well-designed experiments, rather than just opinions or who shouts loudest.
Data over opinions.
Data over opinions, ideally. Encourage teams to run small improvement experiments, like try a new code review checklist for one sprint and actually measure its impact on bug counts, instead of just mandating a new process for everyone overnight. When people see tangible, data-backed results from small experiments, they become much more open to trying new things. As many lean practitioners say, lean is about learning to find real problems and face the limits of our knowledge. That curiosity, that openness to experimentation that needs to become part of the culture.
Data-driven decisions and being proactive about trying new things, yeah, that sounds like a powerful combo for continuous learning. What other cultural elements are important to nurture?
Embedding a continuous improvement culture into the regular routines, the daily or weekly rhythms of the teams. This is really important.
Making it a habit.
Making it a habit, yeah. This could involve making sure sprint retrospectives are truly effective. Maybe using data to guide the discussion, ensuring each retro actually leads to a small, actionable improvement experiment for the next cycle. Encouraging teams to actually allocate time for improvement tasks. Tackling tech debt, fixing known process pains, that's valuable too. Some places even hold Kaizen events short, intense workshops to collaboratively fix a specific problem. The improvement engineer can champion these practices and help teams adopt them.
So making improvement just part of how the team works, not some extra thing they do if they have time. What about getting buy-in from the higher-ups?
Oh, management support and alignment are absolutely essential. Without it, real culture change is almost impossible.
Gotta have leadership on board.
Absolutely. Improvement engineers need to be able to clearly articulate the benefits of what they're doing in terms that resonate with leadership. Reduced risk, faster time to market, higher efficiency, better customer sat scores, cost savings. Demonstrating the return on investment, the ROI, of improvement efforts is crucial for getting that management buy-in and the resources needed. Early wins that are clearly linked to business goals can create this positive feedback loop. Management sees value, provides more support, which leads to bigger improvements, and so on.
Clearly showing the business value, yeah, that's how you get leadership invested. Okay, and finally, in terms of fostering this kind of culture.
Promoting cross-pollination and knowledge sharing. This is vital. Improvement engineering often involves finding a best practice that works well in one team, and then helping spread it to others.
Sharing the wealth.
Sharing the wealth, exactly. Creating things like communities of practice where different teams can share their improvement successes and maybe even their failures as learning opportunities. Using internal blogs or forums to document case studies, encouraging a willingness to learn from setbacks. All of this is crucial for building a culture where learning and improvement are shared across the whole organization. As one insightful quote put it, advantage doesn't always come from advanced infrastructure or larger capital, but from quick change responsibility. And that agility really comes from a culture that can continuously adapt and improve together.
So it's really about creating this whole supportive ecosystem where improvement is valued, it's resourced, and learnings are shared widely across the organization. Okay, now, to make all of this even more concrete, do we have some real-world examples? Can we look at how improvement engineering actually plays out in practice?
Yes, definitely. We can look at DevOps at big tech companies, for example.
Yeah.
Think about Google and their really well-established site reliability engineering, or SRE, practices, or Microsoft's quite comprehensive engineering excellence programs. These show how these principles get applied at massive scale.
Right.
Google's emphasis on blameless postmortems, their extensive use of automation for system reliability that aligns perfectly with improvement engineering, even if they don't always use that exact label. Microsoft made significant investments in coaching their dev teams to write higher quality code and really streamlining their release processes, especially after some earlier challenges. That's a great example of large-scale process improvement, often led by quality engineering experts who had skilled up in areas like cloud automation.
So the big players are definitely putting these ideas into practice. What's another good example, maybe somewhere different?
Well, continuous improvement at Capital One during their big Agile and DevOps transformation is another excellent case study. They explicitly redefined the role of their quality engineers, empowering them to become these champions of improvement within their teams.
Okay.
One really notable example was QE's proactively building automated compliance checks right into their CI pipelines. This was super critical in finance, which is obviously highly regulated.
Huge time saver, I bet.
Massive time saver compared to manual audits. They even started using machine learning to try and predict potential compliance issues before code was even deployed, effectively blending their deep regulatory knowledge with AI. And by fostering a culture of safe experimentation using feature flags, chaos engineering, they really cultivated this team-owned approach to both quality and continuous improvement. The result was a much more efficient and reliable software delivery process overall.
So even in a really heavily regulated industry like finance, these principles can be applied very effectively. What about that Toyota Kata approach you mentioned? We see that in software too.
Oh yeah, definitely. Several software companies, including places like Spotify and also BMW's IT department, have explicitly embraced the Toyota Kata methodology.
Interesting. How do they use it?
Well, they use the improvement Kata for teams to set a clear vision, like say, we want to drastically reduce deployment-related incidents, and then they iteratively run small, focused experiments to move step by step towards that vision.
Small steps again.
Small steps, constant learning. And they also use the coaching Kata, where managers are specifically trained on how to effectively guide their teams through these improvement cycles. And it works. One team at BMW IT reported they cut their incident response time in half just through small, targeted experiments on their on-call procedures. It really shows how that structured Kata approach can build a consistent habit of improvement in software teams, often facilitated by folks with QE backgrounds.
It's fascinating to see a method from manufacturing being applied so well in software development. What about AI's role in quality management in other industries? Any examples there?
The automotive industry is a good one. They're known for their strong focus on Six Sigma and quality control, right?
Absolutely.
And they are increasingly integrating AI into their quality improvement processes. One case study showed how implementing an AI-powered system for root cause analysis significantly sped up fixing software-related issues in manufacturing. And it also helped different engineering teams collaborate better.
Okay.
The quality engineers involved in that transition, they had to learn about the AI tools and techniques, of course. But their roles then evolved. They became more strategic, focusing on validating the AI's findings and recommendations, deciding what to do next. This really aligns with that trend of QEs becoming more strategic thinkers, focusing on how to best leverage information and technology for improvement. Leading car companies are even launching specific initiatives to train their quality engineers in data science to capitalize on these opportunities.
So AI augmenting human expertise, freeing up quality folks to focus on higher level strategy and analysis. That makes sense. Do we have maybe a more hypothetical example, something that kind of ties all these threads together?
Yeah, we can imagine a hypothetical tech startup X. Let's say their QA lead starts noticing that release cycles are getting slower and more bugs are slipping into production.
Common problem.
Very common. So this person takes the initiative, proactively analyzes their whole development and deployment process, and identifies, say, the software build process as a major bottleneck.
Finds pain points.
Finds the pain point. Then they take it upon themselves to learn some new skills, maybe CI/CD tools, cloud containerization, and they actually implement a new CI pipeline that dramatically cuts build times.
Takes action.
Takes action. Maybe they also introduce better production monitoring and a system for using feature flags for safer rollouts. As a direct result, the startup sees a big drop in customer-reported bugs, and maybe they can now deliver software twice as fast.
Big impact.
Huge impact. Recognizing this value, the CTO then formally expands that QA lead's role into maybe an engineering productivity lead or something similar. This kind of story where a quality-focused person drives major improvements by learning new skills and showing initiative. That's becoming really common in tech right now.
That hypothetical startup example, yeah, that really brings it all together. It shows how a QE can evolve and have a massive impact using these improvement engineering principles. It really sounds like improvement engineering is a truly vital evolution in how we develop, run, and maintain software, especially with AI becoming so deeply integrated.
Absolutely. It effectively blends the sort of the rigor of these well-established improvement methodologies with the transformative power of AI and other emerging tech. It presents really significant opportunities for anyone willing to adapt and just keep learning.
And for the quality engineers listening, it sounds like, as you said, they have a really strong foundation to move into these increasingly vital roles as long as they focus on developing those key technical and strategic skills we've been discussing.
Precisely. Embracing this evolution, it leads to faster delivery, higher reliability, and maybe most importantly, it fosters a culture of continuous learning and proactive improvement. We're definitely seeing a growing and really powerful synergy between human expertise and AI assistance in making all of this happen.
So, as we wrap up this deep dive into improvement engineering, here's maybe a final thought for you, the listener, to consider. We've spent this time exploring how these core principles of continuous improvement, now supercharged by AI, are fundamentally reshaping software development. But I'd encourage you to think beyond just technology for a moment. Consider how these same core ideas, finding and eliminating waste, running small experiments, learning from feedback, how could they apply not just to your work, but maybe to other areas of your professional life? Or even to personal interests, personal goals. How could you perhaps adopt a more systematic, maybe data informed approach to continuously improve something else that's important to you? Maybe even leveraging some of the increasingly accessible AI tools out there now. It's really about taking that mindset of relentless improvement, and seeing where else you could apply it to make things better in your own world.